Okay, so now we're going to be starting 7.4. Our objective is to solve quadratic equations by factoring. So our warm-up today is factoring these. Our first one we see is a polynomial that has a coefficient of 1 for its leading coefficient. So we know we're able to do it like this. So it adds to the middle term 7, multiplies to 10, and we can list out the factors 1 and 10, 2 and 5, and that's all we have. So the ones that add to 7 are 2 and 5. Ooh. And so we know that that means this has to be 2, this must be 5. So x plus 2 times x plus 5. Our second one, again, we see we have a leading coefficient of 1, so we can use the x method. Multiplies and adds, so adds to give me negative 3, multiplies to give me negative 15. So we have this telling us different signs. Bigger number, negative. So we have 1 and 15. 2 doesn't go into it. 3 and 5. Okay. I have a feeling this one is a typo. Let's change this 2y or 3y to a 2y. It's the only way this is going to work out. Okay, so our bigger number is still going to be negative. So we're going to put our negatives on the 15 and the 5. So this gives me negative 14. This gives me negative 2. So 3 and negative 5. So we have x plus 3, x minus 5. And then our third one down here, this is that bubble method. So we know it's going to have to add up, adds to negative 7. This tells me that they have the same sign. Signs are going to have to be negative, negative. And then we have our first part, so 2 and 6. So 2 can be 2 and 1. It's the only way to get there. And 6 can either be 1 and 6, or it can be 2 and 3. So we're going to test these out. I'm going to do 1 and 6 first. So 2 times, they have to be negative, so don't let me forget those negative signs there real quick. Negative, negative, negative. So 2 times negative 1 is negative 2. 1 times negative 6 is negative 6. That gives me negative 8, so that's not going to work. So let's switch them up. Let me make that eraser much smaller. There we go. So now we're going to see if it's 2 times negative 6, so that's negative 12, plus negative 1, so that's not going to work. We know this is not going to be our option. So let's go on to our next one. We have, I erased that problem, sorry. 2 and 1. And then we're going to bring in negative 2, negative 3. So we have 2 times negative 2, which is negative 4. So we have negative 4 plus negative 3, which does give me negative 7. So that's the one we're going to have to use. Remember, when we do this, the first numbers come from this one. So we have 2x, 1x, and then the ones that are connected by lines cannot be in the same parentheses. So since the 2 is connected to negative 2, it has to go on the outside. And the 1 is connected to the negative 3, it goes on the inside. We connect them by smiling. And we see that it does create that nose and the smile. So we are good to go. So this is our group. So that's a nice reminder of factoring. Today we'll be solving quadratic equations, and solutions will represent the x-intercepts where that crosses the x-axis. So in a graph, and of our parabola, so parabola looks like this U shape, our solutions are these points right here. It's where they cross that x-axis. We call those the x-intercepts. The zero product property for all real numbers a and b. A times b is 0 if and only if a equals 0 or b equals 0. The only way to get something to equal 0 is if one of the two things you're multiplying by equals 0 as well. This is very important to use. You will use this in the rest of your mathematical career. So if we want to solve example 1 and example 2 here, We know that for this zero product property, A times B equals 0. So A has to be 0 or B has to be 0. So when we see that we have two terms being multiplied, what we do is we set them equal to 0. So you have x plus 2 equals 0 or x plus 5 equals 0. And then we solve for x. So to get x by itself, we subtract over the 2. We get x equals negative 2 or subtract over the 5. And we get x equals negative 5. So if you would have had an x value of negative 2, and you substitute that in, negative 2 plus 2 is 0 times negative 2 plus 5, which is 3. 0 times 3 is 0. We see that's true. The same thing occurs if you substitute in negative 5. Negative 5 plus 2 is negative 3 times negative 5 plus 5, which is 0, and that gives us that. So either one of these would have created a 0 to be multiplied. We're going to do the same thing over here. You break this in half. You have 3x minus 1 equals 0 or x plus 8 equals 0. We got to get x by itself, so I'm going to add 1 to both sides. So we have 3x equals 1. We're going to divide by 3 to get that x by itself. X equals 1/3 or subtract our 8. X equals negative 8. So you have two options that would satisfy the solution. You could substitute in 1/3. 3 times 1/3 is 1. Minus 1 gives me a 0. And then you just have 1/3 plus 8. So 8 1/3 times 0 will give you 0. Or you could substitute in that negative 8. And this one here would be our 0. So we see these are our two solutions here. This one is still the same idea, but we've added another thing happening. So instead of just a times b equaling 0, you have a times b times c equals 0, which means any of these factors could be 0. So you have 5n equals 0, or n minus 3 equals 0, or n minus 4 equals 0. So in this first one, we want to get n by itself. Well, since it's multiplying, we got to do the opposite of that. We got to divide. So n equals 0, or we want to get n by itself. We're going to add 3 to both sides in our second problem. N equals positive 3. Let me not circle it. Or we have a minus 4. So to get that by itself, the n by itself, we're going to add 4. So we have n plus 4. So here you have 3 solutions that would have satisfied this. The 0 going in right here would have created 0 times different numbers. The 3 would have created a 0 here, or the 4 created a 0 here. I noticed I put a plus sign. I apologize for that. Let me change that to an equal. Okay, this is as far as we're going to go today. So when you have this, the 0 product property, any of the terms multiplied together could be 0 to make it a 0. So you have to set each term equal to 0. Good luck on your homework. Let me know if you have questions.